Chapter 3: Thinking Like a Coder. The hardest part about coding isn't learning a programming language. The hardest part is learning to explain ideas to a machine. Computers cannot guess what you mean. All of the steps need to be broken down into smaller chunks so the computer can follow them. Coders think logically and try to anticipate problems that might happen. Events drive many codes. The code tells the computer how to handle an event, such as a mouse click or key press. An if-then statement tells the computer what to do if something happens. For example, when you test out your code, you might notice a small problem. Your character moves through the walls of your maze. You have not told the computer what to do if the character runs into something. To fix this problem, you could write an if-then statement. In Scratch, the command might look like this. If touching color blue, then move -2 steps. Loops. Coders don't like to type the same command over and over again. They use loops. A loop is part of the code that repeats itself. For instance, if you want the character to move forward 10 times, you don't have to type the same command 10 times. You simply set up a loop, and the computer runs through the command 10 times. You can also use loops with if-then statements. Coders can learn a lot by writing a code, testing it, and fixing what didn't work. How it works. Programming an event. Imagine you want your character to move when you click an arrow key. First, you must tell the computer how to react when an arrow key is clicked. You might start by writing it out in English. When the left arrow key is pressed, point the character left and move 10 steps. In Scratch, directions are spelled out in degrees. So, 0 degrees is up, 90 degrees is right, 180 degrees is down, and 270 degrees is left. In Scratch, the command might look like this. When left arrow key pressed, point in direction 270. Move 10 steps. Chapter 5: The Future of Code. Today, more and more devices are connected to the internet and to each other. It's already possible to start a car or turn on the lights at home with a smartphone. The car and the lights are connected to the internet through code. More than 5 billion things are connected to the internet. In the future, nearly every object might be connected through the Internet of Things. This is a network of devices, machines, objects, and even people. They can share data with each other without much human interaction. Each thing on this network would have a built-in sensor. For instance, the sensors in a car might be connected to the traffic system that monitors the roads. If an accident happens, the traffic system could tell your car to take a detour to avoid the accident. In the past, coding has been about telling computers exactly what to do. Google's self-driving cars use code to determine routes and to process the information that sensors gather. These days, programmers are using code to help computers learn from experience. For instance, Netflix has computers that learn which kinds of movies you like. They do this by keeping track of what you watch. Google's supercomputer also learned to beat human players at a board game called Go. Google coders could not write a program to tell the computer how to play Go. This task would have been too complex. The coders programmed the computer to learn. This is called machine learning. The computer learned by playing the game against itself millions of times. Computers still need code, but they will use those instructions, much like humans do, to learn from experience. Biological computing. Another exciting area for coders is biology. In the 1990s, scientists showed how DNA can be used to solve certain mathematical problems. Now scientists are using DNA to store and recall data. Someday, they may be able to program complex codes in living cells. Malware can affect any phone, tablet, or computer if the user is not careful. Viruses and worms are programs